Continuing on with our introduction to derivatives, we might have problems like this and we have to be able to figure out how to confront them. The problem says, identify a function that has the given characteristics. F of 0 equals 2. This means when x is 0, y is 2. So if we're going to graph this, we have this point, here's our x, here's our y, and we're going to be at 0, 2. So we've got a point there. It says that the derivative is -3 for x between -infinity and infinity. So they're telling us for all real numbers, the derivative is -3. We have a constant derivative. Remember, we read into this m tangent. We have a constant -3 slope. The slope of the tangent line is -3. Well, if the derivative is constant, we're talking about a linear function. The derivative is -3 over 1. So I go down 3 over 1, which is the same as up 3, left 1. So our function looks like this. Notice down 3 over 1, -3 over 1. A y-intercept at 2. Again, down 3 over 1. I'm going down 3 over 1. This function satisfies these conditions. So if we're asked to find the function that goes through 0, 2 and has a slope of -3 over 1, well, I would say this is y equals -3x plus 2. Notice, there is my slope, m, and there is my y-intercept, b, 2. So that would finish that problem there. Another problem in a similar vein, identify a function that has the given characteristics. Now we're told f of 0 equals 4. Well, that means, what I read into that is that when x is 0, y is 4. So if I'm graphing this, I'll say I have a point at 0, 4. There's my point at 0, 4. And it says the derivative at 0 is 0. So remember, that's the slope of the tangent line. When x equals 0, the slope of the tangent line is 0. So here is our tangent line. Only horizontal lines have slope of 0. So what does this mean to me? It means the slope of the tangent at x equals 0. When x is 0, the slope of the tangent line is 0. So I've drawn that in. At x equals 0, I've drawn a tangent line that is 0. For x is less than 0, the derivative is negative. So when x is less than 0, here, on this side of our graph, x is greater than 0. Here's our x-axis, and here's our y-axis. On this side of the graph, x is less than 0. Positive x, negative x. It's saying when x is negative, so over here, our derivatives are negative. So here, our derivatives are the slope of the tangent. We're going down, down, down like that. When x is positive, so over here, our derivatives, remember, we're reading into that, the slope of the tangent line is positive. So over here, we have positive tangent lines. So if I'm going to graph a function that's going to meet these criteria, maybe it looks something like this. And we can see that the graph is going with negative tangent lines over here and positive tangent lines over here. So maybe this graph is y equals x squared plus 4. That would be a very reasonable supposition based on this information. And there are other answers too, but this is one decent answer. So we have to find a function that meets all three of these criteria. F of 0 equals 0. This tells me that we've got a point 0, 0. This says when x is equal to 0, y is equal to 0. The function value is 0. So when we're putting in x equals 0, the function value is 0. This tells us we've got a point 0, 0. So if I'm graphing this, I know my point here is 0, 0. There's a point, 0, 0. At x equals 0, the derivative is 0. So again, when we're putting in x equals 0, the derivative is 0. That's the slope of our tangent line. So right here, we've got a tangent line equal to 0. For all other x's, our derivative, remember, we're reading this as m tangent, is positive. So if x is not right there, the derivative, or our m tangent, will be positive and positive. So if I'm going to come up with a graph that's going to have positive derivatives, the slope of the tangent, and positive derivatives, slope of the tangent, and a 0 derivative, slope of the tangent, it might look something like this. Up, and then up again, with sort of a plateau right here where our derivative is 0. Maybe y equals x cubed would be our function. This would be a fine answer. Of course, we could come up with all sorts of piecewise functions too. But y equals x cubed would fit these criteria.